Hello all, welcome to Learning LabVIEW. This is our fifth chapter, storing measurement data. In this chapter, we will learn about how to log your data into a file using a low-level file input-output VIs and high-level file input-output VIs. Now, to log your data into a file, you have to perform three major operations. One is opening your file, then reading or writing from it, and then closing it. You can also check for errors if any. Now in LabVIEW there are certain file formats which are binary, ASCII, LVM and TDMS. In binary is a basic underlying file format for all the other formats. ASCII is a text-based file format. LVM is LabVIEW measurement file which can be opened by spreadsheet application or text editing application. TDMS is basically created for NI products which contains two separate files, binary file and a binary index file. In binary file it has data and all its properties related to it, and in binary index file it has attributes and pointers related to data. Now, in this course, Introduction to LabVIEW, first you will learn only about the ASCII file format. You can use these text files when you want to access your files from other applications also, and also when you are not more concerned about your speed, disk space, and numeric precisions. Now, high level VIs and low level VIs. So as you have to perform three basic operations in file input output, which is opening and then reading or writing and closing. Then in high level VIs you can perform all these three operations using single VI, but in low level VIs you have every functions for each step. So high level VIs are not that much efficient as low level when you will compare them. Now these high-level file input-output VIs are four types: write to spreadsheet file, read from spreadsheet file, write to or read from measurement file. In write to spreadsheet file, you convert a 2D array of numeric data to a text string and then write to a file. In read from spreadsheet file, you read a specified number of rows and columns from the file and then convert it into a 2D double precision numbers. In write to or read from measurement file, you use these VIs when you want to log your data or acquire them from LVM or TDMS file formats. Now this is an example of low-level input-output VIs in which you are using an open VI, open file VI, a write-to-text file VI, and then closing your file VI. For each function, you are using a separate VI. Now this is an example of disk streaming. In disk streaming, you open your file once and also close your file once, and then your loop iterates until your execution of the VI has been completed. Now doing this you save the time as opening and closing of file occur only once. This is your exercise 6-1 spreadsheet example VI in which you will get familiar with high level input output VIs. Now do this exercise by yourself to get it understand. Showing you your exercise 6-1. This is your exercise 6-1. You can see here that I am using a sine wave and also taking some noise, uniform white noise, and then converting the sine into a cosine wave by introducing a phase shift of 90 degrees and building the array, 2D array from these arrays, 1D array, and then plotting it in my waveform graph. Now to log it into my file, I am transposing this 2D array, as here before transposing there will be three rows and that each row will contain a separate plot. So I am, but to display it in separate columns, I am transposing this 2D array and then plotting it in my uh, write spreadsheet.vi. Now, to display it in my table, I am converting this 2D array into a text string and then displaying it in my table. Now I will run this VI. Then it will ask you to name your file where you want to log your data. So I am here using wave2.txt and then saving it in my desktop. So your logging of data has been completed. Now you can view your saved data in the file in desktop. Just showing you where my file has been saved. Now this is my wave2.txt file has been created. When you will open it, you can see that each column contains data as sine, noise and cosine. This was your exercise 6-1. Now this is exercise 6-2 temperature log VI. Earlier you have already make a VI in that you have create in a waveform graph you have created multiple plots which was saved as temperature multiplot.vi. Then you have to modify that VI by taking that current temperature values and logging it into a text file. This is for you to understand disk streaming. Do this exercise by yourself to get efficient in file input-output operations. Now demonstrating you exercise 6-2. This is your temperature multiplot.vi which we have already made in earlier chapter. Now to log my file and use disk streaming, I am using my function open file.vi. Now connect a file path to it. Connect a file path to it wherever you want. This is my open, replace or create VI. So to create a file, you have to select an operation which you want to create. So I am selecting here replace or create option. Now put the ref name out. Now to write your data into a file, I am using my write text file VI. Now getting ready with our data, I am here using a convert function from number to fractional string. Here I am connecting my current temperature value into a text string. Then this is for writing my data in each line. I am using an end of line constant which is available in string palette. Then taking this data and then I am writing it to in my file, connecting the reference out from file open to the write to file. Then closing the file. See here I am using disk streaming as I am only opening and closing my file once. Now for checking my errors I am here using simple error handler VI. Now to stop my loop if any error occurred, I will be connecting my error cluster to this conditional terminal. I am also using an OR boolean function to stop my loop if any error occur or when you switched off this power button. Now, now when you will run this BI, it will ask where you want to save your BI. Suppose now I am using here Aditi dot text and I am saving it here, running it for some minutes. Then I am turning it off. Now you can check where your file is saved. You can see a aditi.txt file has been created. When you will open it, then you can see the data has been logged, current temperature data has been logged into your file. So this was an example of how to write your log your data into a file using disk streaming. Now this is the end of your chapter. There is summary quiz for you. Your first question: your continuously running test program logs to a single file the results of all the tests that occur in 1 hour as they are calculated. Now you are concerned about the execution speed of your program. Should you use low level or high level file input output VIs? Now, as you know, in high-level file input-output VIs, you perform all the three operations using the same VI. So, there may be a possibility that your execution speed becomes slower. But in low-level file input-output VIs, you are using three different VIs for each step. So, your answer should be low-level file input-output VI. Now, coming to second question, I think which is a pretty simple question, which is if you want to view data in a text editor like Notepad, what file format should you use to save the data, ASCII or TDMS? As you know, TDMS is a binary file format, uses binary file, and ASCII uses is a text file, and it can be opened using a text editor like Notepad. So answer is ASCII. Thank you.